Hello, my amazing students. This is Mrs. A, and we are back with Algebra I. We're doing the second half of Lesson 4 because Lesson 4 was so long. So we start off with some symbols that hopefully you are already familiar with, but we're reviewing, and that's why I think that this book puts so much in one lesson, is because they're still kind of in review mode for you, but we are also introducing things that you may see in algebra that you didn't see in just arithmetic. So that symbol, the equal sign, means equals. This one with a slash through it means not equal to. So these are just symbols of equality and inequality that you should be familiar with. Anytime you see that slash, it means not, right? So not equal. We have 4 basic operations in algebra, just like we have 4 basic operations in arithmetic: add, subtract, multiply, and divide. And now we're going to work a little bit on just remembering the terminology for the terms of multiplication, addition, subtraction, and division. So we've got 2 plus 3 is 5. This is an addition problem. The two numbers that you are adding together are called add-ins, and the result is called the sum. We should also take note of a special rule. Anytime we add a 0 to any number, we get the same number. So this, you'll learn a little bit later, is called the addition identity property. When we add 0 to any number, we get the same number we started with. So 4 plus 0 is 4, 15 plus 0 is 15. Adding 0 leaves the number the same. Then we have a subtraction board, and the terms of subtraction, the one that we are subtracting from, the big number, is the minuend. The number being subtracted is the subtrahend, and the answer is the difference. So minuend, subtrahend, difference. Okay, so now we're on multiplication, which we have 4 times 3 equals 12. We know that. The terms that we are multiplying together are called factors, and the answer is called the product. So factor, factor, product. And multiplication can be written a lot of ways. When we get to algebra, we very rarely use this form anymore because we have variables that are very often x's, and when we have a question as to whether is that a times or an x, that's a confusion we don't need. So most often in algebra you'll see 4.3, okay, which means 4 times 3, or 4 parentheses 3, or both of them could be in parentheses, or both of them could be in parentheses with a dot between them. So those are just familiar ways that we can signify multiplication. And we have 2 very important multiplication rules. When we take any number, a, and we multiply it by 1, we get a back again. That's the multiplication identity rule. Okay, and here's an example. 5 times 1 is 5, which we know any number times 1 is the same number we started with. But here we're just putting it into a mathematical statement. So now we have a, which is any number, times 0 will always be 0. So that's our rule. And then here's an example. 5 times 0 is 0. And those are our multiplication rules. And now we're going to come back with division. Okay, the terms of division are dividend, divisor, and quotient is the answer. So 10 divided by 5 equals 2. 10 is the dividend. 5 is the divisor. What you're dividing by is the divisor. And then 2 is the quotient. Dividend, divisor, quotient. Now, when we're talking about fractions, we do have special names for the top of the fraction and the bottom of the fraction. So this is special names, parts of fractions. So the numerator and the denominator. The top part of the fraction is called the numerator. The bottom part of the fraction is called the denominator. And now we're moving into how we actually do math with decimals. So remember, this is just a review. You should know all of this already. So we're not going into great detail, but we are reviewing because it's very important in math to review our concepts, because other concepts build on top of those concepts. And if we don't do a good review, then we get kind of lost. So decimals, remember when we're adding and subtracting decimals, we must always align the places. We must align the decimals so that all of our place values will be the same. If we don't align our values, our decimals, then we could be adding tenths with hundredths, and that would not work very well. So here we're adding 4.0016, okay, and we haven't talked about it much in here, but how would we read that decimal? Let's practice. 4 and 16, now we have to remember which place that is. Tenths, hundredths, thousandths, ten thousandths. So we would say 4 and 16 ten thousandths. This one would be 2,163, and then I've got to name that place. So tenths, hundredths, thousandths, ten thousandths, hundred thousandths. 2,163 hundred thousandths. So it's a little bit fun reading our decimals, right? But now we're supposed to add these together. So we have to make sure that we align the decimals. So 4.0016 and then 0.0263. We had more decimal places behind the decimal in the second number. So if that looks awkward to you, is there any problem with adding a little 0 right there? We can. We don't have to. But a 0 could go there because remember, we can fill in as many zeros as we want after the decimal. Okay, if it's after the last digit that's not 0, then we can just keep on plugging in zeros as long as we want to. So 0 plus 3 is 3, 6 plus 6 is 12, carry your 1, 3, 2, 0, here's my decimal, and 4. So let's name our places so we can read this number correctly. Tenths, hundredths, thousandths, ten thousandths, hundred thousandths. So this is the hundred thousandths place. So remember that. 4 and 2,323 hundred thousandths. And that would be your answer. Okay, so now we're going to subtract decimals. And again, for addition and subtraction, we must align our decimals. So now, look at this. We have to be very careful when we're subtracting. Look at the wording. Subtract this from that. Okay, remember, in subtraction, we have minuend, subtrahend, difference. Which one is the subtrahend? Which one is the number you are subtracting from another number? So basically, when you think about this, this is the big number, and we're subtracting this one. Subtract this from that. Okay, so we're going to put 4.0016 on the top, and then we're going to line up our decimal 0.02163 on the bottom. And again, I can fill in a 0 to make my columns match up. And I'm going to have to borrow. So 0 minus 3 doesn't work. So I'm going to come over here, make that a 5, carry it over. 10 minus 3 is 7. 5 minus 6 doesn't work. So I've got to come over here, take the 1, make it a 0, make that a 15. 15 minus 6 is 9. 0 minus 1 doesn't work. So we're going to have to go way over here to the 4 because there's just zeros. So we're going to make this a 3. We're going to make this a 10. Cross it out, borrow. Make this a 9. And now we can lend that over there. So 10 take away 1 is 9. And then we've got 9 take away 2 is 7. 9 take away 0 is 9. And 3 take away 0 is 3. Okay, so that should be our correct answer, and it is in your book, and that is the correct answer. So now let's read that decimal. Ready? So tenths, hundredths, thousandths, 10,000ths, 100,000ths. Remember that. So 3 and 97,997 hundred-thousandths. There you have it. There's your subtraction there. And now we're going to practice multiplying and dividing our decimals. And when we multiply our decimals, we do not align. Remember, we just write them as they are. Now, your book wrote it this way. This is example 4.3 in your book on page 19. Your book wrote it this way. I would have written it that way. Now, usually they both mean the same thing, and we're going to get the same answer both ways, but I like to put my bigger number on the top and my number with less places on the bottom. Sometimes I'm just weird like that, okay? But should we get the same thing either way that we do it? So let's do it both ways, just to have fun. So we've got 6 times 6 is 36, and carry the 3. And then we have 0 times 6 is 0 plus the 3 is 36. 4 times 6 is 24. Now remember, we do nothing with the decimal until we get all the way done. Okay, so then we're done with the 6. We're going to do 6 times 1 is 6. Now we're moving in 1 because what? That's not 1. That's really a 10. So 6 times 1 gets moved over into the tens place. So we have a 6. And then we have 0 times 1 is 0. And we did not, that carry is gone there. That was the first time. So 6 times 1 is 6. 0 times 1 is 0. And aren't we just going to copy this down because that's a 1? Okay, so we got 406. And then we've got 2 zeros. So we're going to end up with 0, 0, 0, 0, 0, 0. And so now we're ready to add things together. Now, we are going to add columns together. Now, you can, if you want to, you can draw columns. You don't have to. Some students need to draw columns. Okay, if you need to draw columns, it's better than missing the problem. Okay, so we should only have 1 in this column, 2 in this column, 3 in this column, 4 in this column, and so forth. So 6 comes down. 3 plus 6 is 9. 4, and then 2 zeros is 4. 6, 0, 0. Okay, so now, where's our decimal going to be? So we've got 1, 2, 3, 4, 5 decimal places. Remember, we count the decimal places. And then we go from the right. 1, 2, 3, 4, 5. So our answer should be 0.06496. Okay, so now let's do it this way and see if we get the same answer. Now when we do it in this order, our partial products will not be the same, but our product should be the same. So let's do this one. So we've got 6 times 6 is 36, carry your 3. 1 times 6 is 6, plus 3 is 9, and then 0, and then 0. Okay, so then we are going to multiply everything by 0, which means this column is just going to be 0, 0, 0. And then we've got 6 times 4 is 24, so we carry the 2. And then 1 times 4 is 4 plus 2 is 6. And then we got 0, and then we got 0. So now, when we add them up, we've got 6. We've only got 3 partial products, whereas over here we had 4 partial products. So we have it end up with 6, 9, 4, 6, 0, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 0.06496, 0.06496. So look at that. None of the partial products were the same, but the answers were the same. So I generally like to do it this way because look at that. You only have 3 partial products, whereas over here you had 4 partial products. So if you put your smallest number of digits on the bottom, you'll have fewer partial products. And I like that. So now we're reviewing our division with decimals. So we're going to divide this by this. So remember, it's the divisor that goes outside the house. So we're going to have 0.03 outside the house. And then inside the house, we're going to have 6.039. And remember, when we're dividing by decimals, we're never allowed to keep our decimal in our divisor. We need to clear it. So we're going to move this one over twice, and we're going to move this one over twice, and then we're going to put our decimal in our answer up there. So if we were going to talk about what these are, this is the dividend and the divisor, and then the answer up here is going to be the quotient, isn't it? So now we just have 3 going into each one of these terms. So 3 into 6 is going to go 2 times. 2 times 3 is 6. Okay, since these are our front zeros and the decimals behind, we can pretty much just ignore those zeros. Okay, so we got 3 into 6 is 2 times 3 is 6. Remember our division pattern: divide, multiply, subtract, compare, bring down. Okay, so we divided, we multiplied, we subtract. 6 minus 6 is 0. We compare. 0 is less than 3, so we bring down the next one. Oh, look at that. We get another 0. So isn't this one just going to be a 0 to hold that spot? So then we're going to bring down the next one, and it's going to be a 3. So we get 3 into 3 goes 1 time. And 1 times 3 is 3. And then we're going to subtract and get 0. And then we're going to compare. And then we're going to bring down. The next one is going to come down here and be a 9. And 3 into 9 goes 3. And 3 times 3 is 9. And 9 minus 9 is 0. And we have no remainders. So 201 and 3/10 would be our quotient. And that is the correct answer. Now we're learning about unit multipliers. Now we already know from our rules that we just talked about that any number times 1 gives you the same number. Now, isn't 35 over 7 the same thing as 5? So we started with 5. We multiplied 7 over 7, which is 1. And we wound up with 35 over 7, which then can simplify to 5 again. So a number times 1 gives you the same number back again. And that is our identity property of multiplication. Now we're going to use that identity property of multiplication to get numbers into different forms. So here, suppose we did this because we needed a number that represented 5, but that had 7 on the denominator. So we would just multiply by 7 over 7 and get a new fraction that now could add to another fraction that has a 7 in the denominator. So that would be one way to get like denominators if we were talking about fractions, right? We could multiply by 1 in some form that was needed in order to get the fraction into the form that we needed it. We know it's the same value, but it's a different form. So this fraction could be added to another fraction that had a 7 as a denominator. So now we're going to use unit multipliers. These are called unit multipliers. And unit multipliers have units. So you can see I have feet and yards and feet. But they're also, a unit multiplier is a fraction that equals the same thing on the top as it does on the bottom. So the fraction equals 1. So when we multiply by 1, nothing changes, right? So we use these unit multipliers to change the units of a problem. So suppose we had a problem that was in yards and we wanted to change it to feet. So we would multiply it by this unit multiplier because 3 feet is 1 yard. So that's 1. They're the same thing on the top and the bottom. But if I had yards over here, then my yards would cancel my yards and I would end up with feet. And that's what I needed. Okay, so we would use this one, which is the same as this one flipped over. We would use this one if we started out in feet and then we wanted to turn it into yards. We would write the same unit conversion upside down to get what we want. So that's what we're going to be doing in the next section, is converting answers from one to another unit so that we can get them in the form that we want them. So now we're going to convert some things, and we're going to figure out what is the unit multiplier that we're going to need to use. So here on my board, I've got 32 feet is needing to be converted to how many inches is that? So we're going to say 32 feet times a unit multiplier. And we can put 32 feet over 1 if we want to. We don't have to. We can just put 32 feet. But sometimes it's easier to keep track of your numerator and your denominator if you do put it in fraction form. And then we want inches out. So if we want inches out, we want inches on the numerator of our conversion, unit conversion. And then on the bottom, we want feet, because we want feet and feet to cancel. We want to be left with just inches, right? Because that's what we're trying to go to. So we're looking for, what is this unit multiplier here? This unit multiplier, also called a unit conversion factor, but unit multiplier is what your book is using. So now I'm going to say how many inches in 1 foot. So I'm going to put 1 foot is 12 inches. So now I have my formula there. My feet cancels feet. And I know that I'm headed in the right direction because I'm going to wind it with inches. So now all I have to do for my math is multiply 32 times 12. So nothing wrong with coming over here and multiplying on the side. So 2 times 2 is 4, and 3 times 2 is 6, and then I got a 32. And my answer is going to be 384. So 384 inches will be my answer. Now the nice thing about this section is they're not really interested in all of the multiplication, so they're going to allow you to leave the answer as 32 times 12. So 32 times 12 inches. And that way you don't have to spend time doing all of the work. You get to just focus on the unit conversions there. On this screen, we're going to take 36 feet and change it into how many miles. Now, what do we know about miles? We know that there are 5,280, whoops, I said that number wrong. There's no and. 5,280 feet in 1 mile. But we also know that in 1 mile, there are 5,280 feet. So now we have to decide which way do we want to use this unit multiplier in order to get what we want. We want to get rid of feet and we want to get miles. Since we want to get rid of feet, we want to cancel the feet. So we want this unit conversion here. This is the one we're going to use. So let's take this one away. It's not the one we need on this problem. And let's put our problem here. So we're going to start with 36 feet. And we're going to multiply by 1 mile. We'll use MI for mile, over 5,280 feet equals. So now I'm going to cancel my feet. If I want to, I can put a 1 on the bottom if I want to. Okay, so now I look and say, okay, I'm in miles. That's what I wanted. I wanted miles. So now all I have to do is 36 divided by 5,280. So let's just write it down. 36 divided by 5,280, and that is in miles. Okay, so now if they were just wanting us to show them how to do the problem, we would leave it like that, but they go ahead in your book and they go ahead and they do the long division. And when they do the long division, they get 0.0068 miles. And I'll leave that division for you, because the big deal about this one is how to use those unit multipliers to get everything into the units we want it to be in. Okay, so now we're going to look at the next one. And the next one is 47.25. And that right now is in inches, but we want it in centimeters. So we have to know the conversion between inches and centimeters. So we know that 1 inch is 2.54 centimeters. That's a good approximation. Or 2.54 centimeters is the same thing as 1 inch. So we have to decide which one of these unit conversions are we going to need to go from inches to centimeters. So big hint, the one we're trying to go to needs to be on top, doesn't it? And the one we're trying to get rid of needs to be able to cancel on the bottom. So we want to use this one to do our math. So we're going to say 47.25, and we'll put it over 1 inches. And then we're going to use this unit conversion times 2.54 centimeters per inch, 1 inch. Okay, so now can you see that my inches will cancel my inches? And my answer is just going to be this times this multiplied out. Okay, so the very nice way that your author does this is they just let you leave it as a product. So let's go ahead and put that in its finished form here, since we're done with that. So we're going to say 47.25. He doesn't make you multiply it out in this section. And 2.54. And then the answer is in centimeters. And that's the way that you get to leave your answer just like that. You don't have to multiply it out. Isn't that cool? Because the big deal is just learning how to choose the correct unit multiplier that we're going to use. Okay, so now we're going to do another one. We're going from 42 meters to centimeters. So notice that we've done some English measurement and some metric measurements. So we're going to say 42 meters times, and we've got to think about, what do we know about centimeters and meters? Well, we know that there are 100 centimeters in 1 meter. So we could say 100 centimeters, 1 meter. And we could say 1 meter over 100 centimeters. They are both correct, but which one is the one we want to use to get our answer into centimeters? Okay, so we're going to want to cancel our meters, and we want to have centimeters on the top and meters on the bottom. So centimeters on the top and meters on the bottom would be that one right there. So we're going to put 100 centimeters on the top and 1 meter on the bottom. Remember, these are both true, but only one is going to get us what we want in our problem. So we're going to erase this down here, and we're going to do the math. So we get to cancel our m's, which is what we wanted to do. And on the bottom, all we have is 1's. So we can just let those go away. And we end up with 42 times 100 centimeters. But that is so easy. I would hate to leave that just like that, because remember, when we multiply by 100, we just add 2 zeros to the number. So we can go ahead and do that one very easily. So 4,200 centimeters is the answer. Okay, and they went ahead and multiplied it out too because it was so easy. So right now I'm on page 21 of your book if you're trying to keep up with me.